Alo chưa?
Hello, sorry, got some technical problem.
Okay.
Okay, let's carry on. Finish our last part. Okay, let's finish our last part. Yeah, having problem. Okay, let's go to our last part. Right, RCL in series. That's your voltage supply, resistor, capacitor, inductor. Same current, right? Same current passing through each of the component. So that's your I. Use that as your reference. Then we can draw our VR, voltage across a resistor, then voltage across the inductor, then voltage across the capacitor, or wrong order, voltage across the capacitor. Then we can subtract. Yeah? If VL is greater than VC, then we can subtract, we get our resultant, that one. VL minus VC, that's what we want. Right? That vector and this vector, they can form a rectangle. And find the resultant V. Okay. Remember your VL lead your current. For capacitor, your VC, lag a current. Right? That's how we can subtract. Okay, so same current pass through the inductor, capacitor, and resistor. V is the supply voltage. Resistor, R and I are in phase. For inductor, your V leads your I by pi over 2 radian. Capacitor, I leads your V by pi radian. That one you need to remember all this. Right? So we need to act as a vector. So using Pythagoras theorem, your V square is VR square, VL minus VC square. Okay, same as before, nothing much. Right? Replace your VR with I naught R, your VL with I naught XL, VC with I naught XC. Right? Place into that, take the I naught out, and V naught over I naught, we can calculate as impedance. So we get our equation R square plus X minus XC, the whole thing square. Same as before, we define our impedance. Okay, that we can redraw the diagram there. That triangle there is your VL minus VC, this one. And then this is your VR. Or it's just a matter of multiply by current as well. XL minus XC. And this is your V corresponding to your Z. And then this is your corresponding to your R. That's our Z. Phase angle. As I say, you can use cos, you can use tangent. If you use cos, then it's just R over Z, or VR over V. Okay. And if you use tangent phi, right? There's a missing phi here. It's just your XL over R, right? Or VLC over VR. Just cancel the current off. Okay, let's see. Look at some of the graph. Okay, replace your XL omega L, XC by 1 over omega C. Right? XL, that's how XL changes as the current, as the frequency increases, XL increases. How about XC? Remember that's your XC. As your frequency increases, your capacitance decreases. Okay, there is a point there where the two are equal. Right? Where the two are equal, then this is 0 at this point there. Okay, so in this case, your Z becomes your R. Okay, so R does not depend on frequency. XL is directly proportional to F. XC is inversely proportional to F. That's inversely proportional. Z is minimum when XL equals to XC. Z is minimum and your XL equals XC. So at this particular frequency, we call it F naught or resonant frequency. Z is equal to R. Okay, these two are equal to each other. That's what we are doing here. 2 pi F naught L. Call it F naught because it's a resonant frequency. And take your F naught across. Take a 2 pi L cross multiply downwards there. And you take a square root. You get 2 pi square root L over C. Okay, with that so far, anything that is not clear? We have more or less completed. Now trying the question. Okay,
Okay.
okay, try this question. Series RLC circuit contains a resistance 12 ohm, inductance 0.5, 0.15 Henry, capacitor 100 microfarad are connected in series across a 100 volt. It's 100 volt root mean square lah. Right? Root mean square, 50 hertz. Calculate the total impedance. Okay, you should be able to calculate that yourself. Yeah. Calculate your XL, calculate your XC, then use your equation, calculate your Z. Right? XL, put in your value 2 pi, 50 hertz, 0.15 Henry, calculate out using calculator, XC, 1 over 2 pi XC, put in your value, 2 pi, 50, 100, change it to farad, 10 to the power minus 6, use calculator, and use this formula, Z is R square, XL minus XC, you have to memorize the formula. Okay, put in and calculate out. Okay, circuit current, same thing. You know, total resistance, there's impedance, your total resistance. Right? So current is just your V divided by R divided by Z. Right? Root mean square, V root mean square divided by Z. Right? Usually, as I say, this is root mean square value, it doesn't tell you. Put in your value, 100 divided by Z. Okay, anything not clear?
No, okay.
Right? Draw the voltage phasor diagram. Right? That's a voltage phasor diagram. Right? You should be able to calculate the value out. VR is I times R. Right? I will record that. R is your there. Now multiply out. Then VL, voltage across the inductor is I times XL. This is your XL. And that's your current. Multiply, get this value. So you should be able to write this value all down here. Right? XL. Then XC. I times XC. Right? That's your current. That's your XC. 164 volt. Okay. Put your value inside here. Can or not? If can, we have more or less completed. Let's go and do question. What is happening? Tired.
Yes, teacher.
Yeah, just put in your value here. That's your VC. That's your VL. That's your V. Right? Replace it with 100. And then your phase angle. Phase angle, same thing. Or power factor. Okay. So all these summarize for you. All these that you need to remember for this topic. Anything you want to ask? If not, let us try the. You can try the checkpoint question. We will try the focus question. Okay, let's go back to where we stopped. Okay, question. Distinguish between impedance and reactance in the AC circuit. Yeah. Can or not?
Can. 15. Yeah.
Yeah. What is impedance?
1 over 15 times 10 to the power of 3 times 0.50 times 10 to the power of -6. Then you get that. And then
You ask you to distinguish between them first before you calculate. So impedance is opposition of a component in the circuit to alternating current. Okay, you can write down the formula and tell what is R, XL, reactive inductance and reactive capacitance. And then reactance is opposition of capacitor or inductor or both to alternating current. Calculate Yx equals to V naught over I naught. Okay, with that? Okay with that?
okay.
Now calculation part. Okay, tell me the answer. Impedance of circuit. What's the answer? Calculate the reactance of C capacitor. Put your value. 2 pi 50 hertz, 50 hertz, C 0.5, 10 to the power minus 6. Calculate out using calculator and use that equation. Okay. The root mean square value of the voltage supply. Okay, you've got the current. So current times Z. Okay, your current changes to ampere. That's your Z. Changes to ohm. The phase difference between current and voltage. Okay, as I say, if you are very particular, use voltage here. Use voltage here. But it's still the same answer. X, C we have calculated, Z we have calculated. Root mean square voltage we have calculated. Tangent phi is just your XC over R. In your value. XC, that's your XC. Your R is given here. Okay, as long as you use all kilo ohm, you're all right. And find your angle. I don't know how they get 77. Okay, my answer is 23. You can check and see. If anything I make a mistake, let me know. Power dissipated from the resistor. Then power is I square R. Right? I root mean square times your R. That's your current. Change it to ampere. Right? That's your kilo ohm. Change it to ohm. Okay or not? Anything not clear?
Okay.
Okay, let's try the
Tired lah, Cher.
finishing soon, finishing soon. Why you choose a day when you are tired?
Yeah. I mean tomorrow vaccine lah, Cher. I don't know, you know.
Should have gone on Saturday, then you won't be tired.
No, then after that I have to take vaccine.
Never mind, after 10 more minutes, then we can stop. Okay, this question number 24 under your focus. Resistor or resistant R, capacitor or capacitance C, and inductor or inductance L are connected in series to alternate voltage of constant root mean square value, but variable frequency. The root mean square current in the circuit is maximum when the frequency is memory work only. What's the answer? Yep. Too tired to think.
Yes, teacher, so sorry.
I think next time we will change the date, the time idea. We use Saturday easier. Yeah, more fresh. Right? That one is equal to that. Or memory work only, nothing much. Where your R equals to 0. Right? This is equal to that. So that's why we get donkey. Okay, try this question. A coil of resistance 8 ohm and inductance 24 millihenry is connected to a 12 volt 50 hertz AC supply. Find the value of the impedance. Right? First calculate your reactance. The formula 2 pi FL. Put in your value and calculate 2 pi. F is 50. L, change it to Henry. Right? Calculate in ohm. And that is R square plus XL square. Put in your value and calculate out 11 ohm. What is the root mean square current in the circuit? Right? V divided by Z. V we are told is 12 volt out from the voltage supply. Divided by Z, that's your Z. 1.09 ampere. Right? Phase difference, your angle, tangent, XL over R. Put in your value and calculate out. Okay with that? Any comment? Anything not clear?
Clear, teacher.
Okay, I think you have done this one. Don't bother about that anymore. You've done this one. Okay, let's try Try number 6. This one. Press the wrong button. What did I do? Okay, number 6. A resistor, a capacitor, and an inductor are connected in series with a AC supply. The frequency of the AC is 50 Hz. Root mean square potential difference across the resistor, capacitor, inductor are shown in the diagram. We are given this is a root mean square value. Root mean square current is 0.5 ampere. With the aid of phasor diagram, find the root mean square voltage of AC. Ask you to draw VR as a reference horizontal. Then there's your V, there's your VL, there's your VC. VC is larger from the diagram. VC is larger. So you take VC minus VL. VL minus VC or VC minus VL. Anyway, negative sign will disappear when we square that. Okay, so your V is VR into VR square, VC minus VL, the whole thing square, then square root that. VR is 40, VC is 55, VL is 25. Okay, out. Okay, how to calculate the resistance of the resistor? Yeah, I think we'll call this last question the last one. No point. You are too tired already to think through. Okay, same. VR, potential difference across R divided by root mean square current. Put in the value, 40 here. Okay. And then your resistance, your current is given there. That's your current. Capacitance of the capacitor, find your XR first. Find your XC first. XT is VC over I root mean square. That's your 55. That's your current. That's your current. Okay, out. And from this equation, you can calculate your C. Substitute your 50, F50. XT is 110. Get this value. And inductance, the same thing. Calculate the reactance first. Inductive reactance, VL over there. 25 over 0.5. So 25. So 0.5 in the circuit, the current. Okay, we just cross multiply, that's all. Get our answer. Anything not clear?
Okay.
Okay, we have completed, so I call it a day since you are too tired already.
Thank you, Jer.
So we see you next Wednesday.
Okay, thank you, Jer. Jer,
Yeah.
like when I do right, teacher, I don't know, that day chapter 1, right, Jer?
Ah.
I was like really want to study. And when I look at the book, it's already get scared and got headache so fast already. Like not even 1 hour, but headache already so fast looking at it.
You have to overcome your fear of. No other choice. This is the last
I mean,
one.
like I really want to study it, but then look at it, it looks so tough, and then I get scared really easily like that.
Overcome your fear. Revise, and then do the past year paper. You got
oh, my
somebody
friend told right, teacher, like when straight away do revision, right, and some basic question do past year, like so that you will overcome fear.
Yeah. You do the past year question, then you know roughly what's the exam requirement, right? You revise first so that you can remember the formula. Or you can do the past year paper, can refer to your guidebook to help you. Okay.
Okay. Okay, thank you, teacher.
It's not tough. It's not tough. You can do it if you put in the effort. You stop here.
Not not tough, teacher.
I have been doing it. Some of the topic I never teach before, so I have to learn all the thing myself.
Okay, I believe you, teacher.
So if I can do it, I'm sure you can do it also. It's a matter of you putting in the effort.
Teacher, but yesterday, right, teacher?
Yeah.
Everyone putting petition, they don't want to go back to school because COVID cases increasing. So I don't know whether they're going to delay it or not. I also don't know. But I'm getting ready lah in case
Don't
1
worry
September
lah.
to go back.
It will be either you go back to school or they go online, that's all. Don't worry
And
about
they
this.
have exam October and go back on October only
October
lah.
will have to go back to school.
Only for the exam, right?
Only for the exam, definitely lah.
Oh, first time lah, teacher.
Even Sunday also they have to go back. No choice because online checking on student, student can play the trick. So we don't trust that lah. Even though we can have checking on them, they can go to toilet where we have no way of checking on them.
Wait. So Sunday means that means their exam only they will ask them to do face to face, but online lesson online only lah.
I think now it's online lesson.
But the exam
they have to come back because last time they have CIE have internet. Last time they use internet assessment, and then they
same
create a
for
lot of
Osman
problem.
and the foundation also, teacher.
They create a lot of problem. So that's why end of last year they get the student to come back to the school, to the college to do the question. So they don't cancel anymore.
Oh, I see. Okay.
Not like y'all postpone it, they don't postpone it. They use internal assessment. Which a lot of people cry out, not fair. So now they have you have to go back and sit for the exam.
Thank you, teacher. I believe in you, teacher. Thank you.
Okay, put in the effort. I'm sure you can do that if you put in the effort. So far, you have not been putting in the effort. Okay.
Yes, teacher.
Bye-bye.
Okay.
Make sure you do your
Bye-bye.
checkpoint. Make sure you do your checkpoint. Your AC. Finish all your checkpoint. We
Yes,
will do it
teacher.
on
Okay.
Wednesday. After that, can start revision. Okay.
Okay.
Bye-bye.
Sure, teacher. Thank you. Bye-bye.